Welcome to MPH Day Today 2023. Today, the presentation I'm going to give it will be on data integration methodologies, standards, and best practices. Myself, I'm Kranthi Mallarapu, a senior data engineer with MPH for the past 8 years. So let's get started. The agenda today will be three main aspects of any data project that will be focused on data architecture, data ingestion, and organizing and storage across the data initiative. So in the limited time we have, so we'll focus on this. That's part of the agenda. So let's dive into data architecture. What is data architecture, right? Why should an organization care about data architecture? What does it provide? A basic definition of a data architecture would be like it's the framework or a playbook for how data moves within a system. It's like a foundation that supports your business goals. So it provides answers to questions like how is data collected? Like where is it coming from? Where is it stored? What technology moves the data from one point to the other? What transformations are applied? How is it distributed and consumed by the end users? So these are very core questions anyone would have that a data architecture would help answer. Like, so any good data strategy is underpinned by a strong data architecture. So if you look at any data architecture diagram, it can be as simple to as complex as you can make it, depending on your different data sources, your tool sets, your use cases and all. But if you look at a data architecture diagram from a 10,000 foot level, it boils down to this. So any data initiative will have a data source, will have a data ingestion methodology. You get the data source and move it from one place to other. There's nothing but data ingestion. Then you store and organize it. You have a bunch of transformations depending on the use case, and then you deliver the end results to in form of data products to the end users. So the data sources, when it comes to it, it can be a multitude of data sources, public data sets, social media, IoT, sensors, and various applications. Data ingestion tools, ETL, ELT tools, so many out in the market used for data movement. And then you load into your data warehouse or different data models that you have that are transformed and organized into data marts. And then finally pushing it out to the data products using some sort of BI toolset. So the dotted line around the diagram here that provides assume some sort of security around your systems, and the vertical lines representing separate different access levels within that security framework. So in the whole data architecture, today we'll focus on two things: data ingestion, organizing and storage. Now let's jump into data ingestion. Now using simple terms definition, right? Data ingestion is nothing but you make a connection to a source system, extract the data, load it into a target system with or without transformation. Now there are two methodologies typically used. One is ETL and one is ELT. Now, ETL stands for extract, transform, load. ELT stands for extract, load, and transform. Now let's jump into the differences or the methodologies comparison here. what to choose, when to choose, and what best suits your use case. ETL and ELT, as we discussed. Now, the major difference between these two methodologies would be where does the data transformation occur. If you see ETL, you extract from your data source, you transform based on your use case, the business logic or regulation requirements, whatever it is. You transform the data and then it's loaded into a target system, whatever that might be, a data warehouse, data lake, data mart, anything. Now in ELT, you extract the source data, you load the data as is in your system first without any transformations. Once it lands in your system, then you apply transformations based on different use case. And then your final end system is hooked into the end data products that you want to send out for consumption by other. Now, how to decide what best suits your data initiative? So we can have different aspects of comparisons. We have some, let's go through them. So some of the metrics that you need to consider as part of your data initiative to choose which methodology would be best suited for my project. So first is like data volume. So ETL will be best suited for low volume initiatives, ELT for high volume initiatives. Again, the reason being where the transformation occurs. If there is high volume data, then applying your transformation rules on such a high volume will take a lot of time to process. Whether an ELT, you land it in your target system, then you pick and choose what transformation to apply to which data and how to make it happen. So that is more, ELT is more helpful when the volume is high. Now again, data variety. ETL is limited, right? Even when you connect your ETL tool to a source system, you apply a transformation logic, it needs the data to be structured in a certain way because of the transformation rules we are applying. But ELT, no matter what data, what structure, what way it is organized, you just land it in your system first, then you pick and choose bits and pieces within it. And then comes the use case. For ETL, it's limited. For ELT, it's diverse. Again, the reason being where the transformation occurs. So if you see ETL, since the transformation is applied even before you load it into your system, your rules, your use cases are built into that transformation logic. Whereas in ELT, you load all the data and then you pick a, based on your use case, you do different transformations on that data and then make it available to your end users. Now, data quality. Since you apply the transformation even before it lands in your system, the quality is high in ETL. In ELT, you load the data as is in your system, so the whole system quality is limited by that fact that your whole source system data is landed in the target without any transformation or data quality rules. Again, you keep applying the transformation rules on bits and pieces of the data and you improve the quality, but overall as a system, it's limited. It's not as high quality when you use ETL. Now coming to compliance. Now, since the transformation rules are built in before the data lands in ETL, your compliance rules can also be built into those transformations, and ETL will be compliant to whatever regulation you need to be compliant against. But ELT, not always. The whole system might not be compliant. You can make some parts of the system compliant by applying the transformation after it lands in your system. So that's why I've written it maybe. So bits and pieces are compliant in ELT methodologies. Again, my favorite analogy here for data ingestion comparing ETL and ELT is a food analogy. So for example, your source is carrots, right? If you apply transformation of extracting juice from your carrots and land that juice in your target system. So now in your target system, you have carrot juice, your source was carrots. So what you can do with the carrot juice is limited. Whereas in ELT, you take your carrots from source and you land them as is in your target system. And then carrot juice will be one of the byproducts of the transformation. You can have bits and pieces of carrots, put it in a soup, make carrot cake, use the carrot juice in however different ways you can think of. So the use cases are very diverse when you use ELT. ETL, it's very limited. So coming to different technologies that use or support this ETL or ELT, for example, Microsoft SSIS, Informatica, Oracle Data Integrator, all these are ETL tools. And ELT tools in the market, Microsoft Azure Data Factory, uh, Amazon Web Service Glue, there's Talend, and all these different technologies available in the market for these methodologies to be implemented. Now, once you have your methodology decided on, now we go and check how the data is stored and organized. Organizing and storage, the first thing that comes to mind is naming conventions, right? Some rules, like rules or standards, like they exist to identify and categorize. Like when there are no standards, like different people with different preferences do things differently. Like the things get messy real quick. So within when you plan your data initiative, how to organize and store that data, so these things come to mind, the naming conventions. In the naming conventions, if I go through some examples here, like if you see the first naming option, if you see the description or the naming of the objects here in the example, I don't see any standard or a convention going on here. If I didn't give you on the left side the pipeline, the script, the database table, or the files, you would not be able to tell me what it was. Now, see the script and the files, they are named exactly the same. If you go to the naming option 2, it follows some standards like all uppercase, short abbreviations, like underscores between each words, but it's still missing something. Now, if you look at that, the tables are starting with TBL in one case and with T in one case. It's not consistent. The same thing is represented differently using a different acronym. It's better to be wrong and consistent than being inconsistent, because the time it takes to fix something that's inconsistent is very, very long. So if you now you look at option 3, this checks all the boxes. It includes as little as possible but as much as needed. It has all the same conventions of option 2, but it's consistent. So that option is much better compared to the naming option 1 and 2. So the things to keep in mind when doing coming up with naming conventions, right? Pick what best suits your initiative and document it. When you document, it leaves very little room for interpretation. It clears things up. There's no room for interpretation anymore. While there's no replacement for really good data documentation, the application of consistent conventions goes a long way towards empowering your users. Now, once you document what you do, you inform, you explain, you follow up, see what works and what does not across your teams within your organization. So once you have a good naming convention, then you can think about another standard, that is coding standards. And any code you take, whether it's SQL, Python, R, C, C Sharp, .NET, Java, whatever it might be, there are core principles that work no matter what technology you choose. Like the three things I'd like to focus on today is, first one is modular. Like keeping things modular will help in reusability of the code. You have to do less coding since the same thing can be used in different places, and it becomes easier to manage. You write the code once, and then when it's called from different places, if you need to fix that piece of code, you just fix that module, and everywhere wherever it's being called from is already fixed. Then comes comments. Like comments are documentation within your code. I don't think anybody would disagree with the importance of documentation, but still, it's like a double-edged sword. If you update code but not documentation, that will cause a lot of confusion. So you have to be very careful when commenting. It's really, really important to comment, and also important to make sure the comments and the code are in sync. They say the same story. And the last one would be formatting. What formatting helps is readability. So when you follow these standards, no matter who is coming into your data project or leaving your data project, it becomes easier for everybody to manage these. Now, if we go through some example code, I'm very familiar with SQL, so I've just given a SQL example here. So if you see, it's just all written in one line. There is no formatting, there is no comments, there is no modularity, the things that we discussed earlier. Now let's improve on these. If you look at the second option, there is some formatting. Now you know, okay, it's two tables are used, four fields are used, and some filter condition going on here. But still it's missing something. It's missing comments and it's missing modularity. Let's improve on this. Now look at the final option. This is better compared to our first two options. It has comments. You know why it was created, when it was created, the reason, a description of what the code is doing. Then we have the first module. In SQL, we call it common table expressions. And then finally, the main select. So it's whenever someone comes, a new developer comes in and looks at this code, he has all, or he or she has all the pieces required to know what the code is doing and why it was even developed in the first place. So when we have all some good naming standards, good coding standards, good data architecture principles, choosing good data integration methodologies for your data initiative, all these are really the core basics of any data initiative. And we will never get away from doing the basics, like the fundamentals never change. So organizations that do the fundamentals right have powerful engines that make a difference and are sustainable for a long, long time. Like according to Gartner, 85% of big data projects fail to get off the ground. Like throwing money and buying technology for the sake of buying it will not help solve your problems. Like great success, there is a secret to it. It's called hard work. Rolling up your sleeves, doing the little things and all the core basics that we discussed today, like following data architecture principles, choosing your methodology, establishing standards, and building them into the very heart of your strategy and culture. These will accelerate your data strategy and give you the platform you need to meet modern customer demands faster and more efficiently. I hope our presentation today has helped you in making good data decisions and help you choose the right people and right technologies and right methodologies in helping your data solve better problems. Thank you so much